Similar to the previous question, we are given a graph and a accumulation function, and we're asked to find the x value where this function h, which is the accumulation function, has a relative maximum. Remember, anytime we're trying to find any relative extrema, what we need to do is we need to look for the derivative. And we're looking for the derivative not of f, but of h, which is this function they're asking about. And so we're going to say h prime of x. Well, we know that h prime of x is going to be the derivative with respect to x of this integral from 0 to x over 3 plus 7 of f of t dt. Now we've learned the fundamental theorem of calculus, at least the second part, and the second part of the fundamental theorem of calculus tells us that when we are finding the derivative of an accumulation function like this, we are going to input our bounds into the integrand, or the function on the inside of the integral, and apply the chain rule. So we can do that. I can see that h prime of x will give us f of x over 3 plus 7 times the derivative of that, which would be 1/3. So I'm going to rewrite this just because I like to have my constants outside. Alright, so here we are, 1/3 times f of x over 3 plus 7. What do we need? We need this derivative to equal 0, because we're trying to find a maximum. Derivative has to equal 0. So 0 is equal to 1/3 times f of x over 3 plus 7. Let me start using a different color here so we can see these steps. Divide both sides by 1 over 3. It doesn't matter, so 0 equals f of x over 3 plus 7. And now we need to find when does our function equal 0. Well, there are 3 different places where that happens. I see that happening here, here, and here. And then you might be like, well, how am I going to find the one x value where this happens? Well, we have to remember, we want a maximum, which means that the derivative, in this case, which is f, or f is behaving similar to the derivative, must be changing from positive to negative. So where do we see that change from positive to negative? I'm going to write that derivative is 0 and changes positive to negative. And so let's figure out what's happening. Over here I see we're going from negative to positive, so I don't want that one. And here as well I see negative to positive, so I don't want that one either. At 4, I see that the derivative goes from positive to negative. And so we know that whatever's on the inside here should equal 4. So we're going to do that. X over 3 plus 7 equals 4. I'm going to divide, or subtract 7 from both sides. 4 minus 7 is going to give me negative 3. So x over 3 equals negative 3. And I'm going to multiply both sides by 3. And our final answer we get as x equals negative 9. And so we see that the function h will have a relative maximum at x equals negative 9, thanks to the fundamental theorem of calculus.